It'll be a series of videos, maybe 3 or 4 different parts. We're going to talk about integration by partial fractions, okay? And we should know by now that we have linear factors, okay? The ones that factors, okay? Another way of saying that. And we have quadratic factors. Okay, now the general formula for linear factors is that I'm going to take the integral of some sort of 1 over x squared minus a squared dx. Okay, and the idea is that I could decompose it. If it's linear, I could decompose it into the integral of 1 divided by x minus a times x minus a dx. Okay, so that's the idea of linear factors. Now quadratic factors, on the bottom we have some sort of 1 over ax squared plus bx plus c, where b squared minus 4ac is actually less than 0. So it's not factorable, okay? So this is what we do with quadratic. And this is linear, okay? So that's the general idea. Now, it doesn't have to be 1. I just use the simplest term. So this could be anything on the top. It could also be a polynomial, okay? So let's look at a couple of problems that actually decomposing these partial fractions. And so what if we're given the idea of 16x over x plus 1, x minus 1, x plus 2 dx? How could we decompose this? Well, the idea is that if I'm looking at these are all linear factors. And so the idea is that we put some sort of letter. Usually we start with a over the first one. So this is a over x plus 1 plus b over x minus 1 plus c over x plus 2. Okay, so this is how we actually decompose this partial fraction. Okay, let's look at another one. So in this case, how could we decompose this one? How do we decompose it? Dx over x minus 1 cubed times x squared plus 3x plus 2. How could we decompose this one? Well, to me, I always look to see if I have any factor, and I always look to see if I could factor anything. And to me, it looks as if the factors of this is actually x plus 1 and x minus 2. Okay, so I could actually, in fact, I could rewrite this as dx over x minus 1 cubed times x plus 2, x plus 1. Again, 2 times 1 is 2, 2 times 2 plus 1 is 3. Okay, so always look to see if the denominator is factorable. Okay, now this one is actually raised to the cube power. So this is actually in its most simplified form. And so how do we decompose this? We say the integral of dx over x minus 1 cubed times x squared plus 3x plus 2. Well, that is equal to a over x minus 1, okay, plus b over x minus 1 squared. So we gotta write out the factors up until the last power. So this is a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed, okay, plus d over x plus 2 plus e over x plus 1. Okay, so this is how we'd write out a complete factor for this problem here. But again, look to see if your denominator is factorable. Okay, how about, let's see, how about this one? How could we decompose this? What if we have the integral of x plus 7 divided by x minus 1 times x squared minus 6x plus 9 dx? How could we decompose this? Well, to me, it looks as if the factors are actually, if I factor this is factorable, right? X minus 3 and x minus 3. Yeah, because if I take negative 3 times negative 3, I get 9. If I add them, I get negative 6. And so this is actually equivalent to x plus 7 divided by x minus 1 times x minus 3 times x minus 3 dx. Now the idea is once I get it in this form, once I see that it's factorable, because I have two of the same factors, I'm actually going to bring them together and raise them to the second power. Again, the same thing, if I had 3, I would bring all 3 together and raise them to the third power. So the idea is that you want to simplify. And so I could simplify this to be written as the integral of x plus 7 dx divided by x minus 1 times x minus 3 squared. Okay. And so the bottom now is in its most simplest form. And so if I decompose this, this will be a over x minus 1, because that is linear, plus b, well again, this is linear, it's just raised to the second power. So this is b times x, b divided by x minus 3. And this becomes c over x minus 3 squared. Okay, and this is how we'd actually decompose this integral here. Okay, so what about this one here? What if we want to take the integral of 12x plus 4 over x times x plus 3 dx? How would we decompose this one? Well, again, the first thing I'm going to do is factor at the bottom. And so if I look at this, I see 12x plus 4 dx. I'm going to divide that by x. If I factor out an x, this becomes x times x squared plus 1. Okay. So all I did was factor out an x. So if I distribute, I get x squared plus x. Okay. And so this is what my bottom is in now. Now look, x is a linear factor. Okay, x is a linear factor, but this one is actually not. This one, b squared minus 4ac is actually less than 0. Okay, so if I look at this, this is actually quadratic, this is linear. And so how do we deal with it? Well, I'm going to rewrite my integral as 12x plus 4. I'm going to divide that by x times x squared plus 1 dx. And I could factor this into now a over x, because x is linear, plus, now whenever you have quadratic factors, here's the idea, you want to keep it in this form. I've already written a, so I'm not going to use a again, so this becomes bx plus c over x squared plus 1. Okay, this is how we'd actually decompose it. Now I want you to get the idea. It's always going to end in this form. Okay, now because I already use a, I'm just going to use the two variables that come after it. So it's always going to end this form, some letter times x plus a constant. Okay, so what if, so my point is, if I had a over x and I had b over x squared, then this quadratic function would actually be cx plus d over x squared plus 1. Okay, and so that's the idea. This is how we treat quadratic function, with some sort of letter times x plus a constant, and we're going to divide it by the actual quadratic factor itself. So to kind of get this concept in our head, let's look at what I'm talking about. So what if we wanted to decompose this? Dx over x minus 1 cubed times x squared plus 2x plus 2 squared. Okay, how do we deal with this one? How would we decompose this? Well, to me, I see 3 linear factors. This is x minus 1 raised to the cube to the third power, so we're good with that. However, if I look at this, this is not factorable. Okay, I cannot factor this polynomial. Try doing it, you can't. Okay, and so because 4b squared minus 4ac is less than 0. Okay, and so this is not factorable. So if I look at this, the way I'm going to split this up is that if I rewrite my integral as dx over x minus 1 cubed times x squared plus 2x plus 2, well, I'm going to split this up into a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. Okay, and now that I'm at my quadratic factors, well, this becomes dx plus e over x squared plus 2x plus 2. Okay. And now, because I have two of them, I gotta go this to the square term now. So this becomes, well, after D in the alphabet comes F, so this becomes fx plus g over x squared plus 2x plus 2 squared. Now, I said something funny a while ago. The next letter, again, the letter doesn't matter, so I could actually use, so this is dx plus e, so in this case I could actually use d2x plus e2 divided by x squared plus 2x plus 2.